In this video, we will look at two examples where we compute the area between two curves. We just found that the area between the graphs of y equals f of x and y equals g of x from x equals a to x equals b is the integral from a to b of f of x minus g of x dx. Remember here that we are using that f of x must be bigger than g of x. In our first example, we'll find the area between the curves y equals x and y equals e to the x on the interval from x equals 0 to x equals 2. Let's start by looking at their graphs and shading in the region between the two curves. We are looking for the area of this purple region. It is important to point out that the function y equals e to the x is greater than the function y equals x. So when we compute the area between the graphs of y equals e to the x and y equals x from x equals 0 to x equals 2, we find it as the integral from 0 to 2 of e to the x minus x dx. Evaluating this on our calculator, we get that it is roughly 5.389. So this means that the area between the curves y equals x and y equals e to the x on the interval from x equals 0 to x equals 2 is roughly 5.389. In our second example, we want to find the area enclosed by the graphs y equals x and y equals x squared. Again, let's start by looking at the graph and shading in the region enclosed between them. This is the area that we want to find. Using what we know about the area between two graphs, we know that the area between the graphs of y equals x and y equals x squared is the integral from a to b of x minus x squared dx. But the question here is, what is a and what is b? In other words, what are the endpoints for this interval? To find what a and b are, we need to know the x values where the curves intersect. That is, we need to know the x values where our two functions are equal. So we have the equation x equals x squared. Since this is a quadratic equation, we can get 0 on one side, so subtracting x, we get x squared minus x equals 0. We can either solve this using the quadratic formula or factoring to find that x equals 1 and x equals 0. So to find the area enclosed by the graphs, we are looking from x equals 0 to x equals 1. Putting this into our equation above, we have the integral from 0 to 1 of x minus x squared dx, which we can evaluate on our calculator to find that it is 1/6, or roughly 0.1667. So we have found that the area enclosed by the graphs of y equals x and y equals x squared is 1/6.